A pleasant day to you, icons and lady icons. Welcome to the fourth module of our discussion on the subject special topics in natural science, and we are going to discuss here the concept of gases. Please take note that in this particular discussion, this is actually included on the discussions that you had during your Science 10, and if we are going to recall, there are different properties that are present among gases. A gas uniformly fills any container, is easily compressed, and mixes completely with other gases. One of the most obvious properties of gas is that it exerts pressure on its surroundings. And whenever we are going to talk about pressure, a pressure, it is not actually the pressure that is technically related whenever we are talking about stress or when it comes to academic work. The pressure that we are simply talking about here, it is measured by means of the following units. It could be measured as 1 standard atmosphere, it is equivalent to 1 atm, 760 millimeter mercury, or it could also be equivalent to 760 torr, 101,325 pascals, or 10 raised to 5 pascals. So technically, that is the different unit that we are considering whenever we are talking about pressure. The main discussion that I'm going to focus in this particular discussion, it would be all about the concept of the different gas laws. We're going to talk about the presence of the different gas laws, and I am actually going to help you, and I am going to guide every single one of you on how you are actually going to manipulate different formulas that are related to the gas law, and at the same time, how are you going to answer problems based on the different characteristics that are present among different types of gases. So these persons are actually the one that is responsible for the different gas laws, and let's simply start first with the Boyle's law. Boyle's law, it is attributed to Robert Boyle, in which he observed the relationship between pressure and volume of gases in constant temperature. He observed that if the volume of a gas doubles, the pressure of gas drops by half. Whenever we are talking about the Boyle's law, there are actually two variables that we are going to take into consideration. The first one, the presence of pressure, and the presence of volume. Pressure, it is represented by capital letter P, while volume is represented by capital letter V. Then, whenever we are talking about Boyle's law, we can actually conclude that the first pressure and the first volume is equivalent to the second pressure and the final volume. Whenever we're talking about the certain type of relationship, the pressure of a fixed amount of gas is inversely proportional to its volume at constant temperature. So for us to represent this inverse proportion, we are considering the certain type of formula. It could be written like this, or it could be written like this one. Okay? So definitely whenever we're talking about Boyle's law, it is just about the relationship between pressure and at the same time volume. For us to manipulate this, we're always going to start with the basic formula, which is P sub 1, V sub 1 is equivalent to P sub 2, V sub 2. Okay, so for instance, we are looking for us to get the formula for P sub 1, we should always eliminate the other terms that is present on the side of the mathematical equation. So for us to manipulate this formula, we should divide both sides of the equation with V sub 1 for us to cancel them out. Then, it will give us now the formula which is P sub 1 is equivalent to P sub 2, V sub 2 over V sub 1. Okay, so now what if we would like to know what is the V sub 2 or the final volume? Okay, so please take note. 1 represents initial, while sub 2 or the subscript 2, it now represents the final. Okay, initial pressure, initial volume, final pressure, final volume. We should now eliminate here P sub 2 that is present in the side of the equation. And for us to do this, we're going to divide both sides with P sub 2. Then the P sub 2 here will be cancelled. Then copy the remaining part of the equation, which is P sub 1 times V sub 1 over P sub 2. Okay, so technically that is how we are going to do manipulation when it comes to the formula for Boyle's law. Now, let's consider this problem, which is present on page number 3 of your module. A 67-liter gas is kept in a movable piston that has an initial pressure of 1.25 atmospheres. If the piston is allowed to expand at constant temperature to 88.5 liters, what will be the resulting pressure of the gas? Okay, so based on this certain type of problem, we can actually acquire the following given. Once again, we're going to start by means of utilizing the GRESA method when it comes to our solutions and answers for these different problems. Please take note, we are now going to use GRESA method, okay? G stands for the given. And the given for our problem, the first one, we have the presence of V sub 1, which is the initial volume, which is equivalent to 67 liters. Then, there is the initial pressure, which will now be equivalent to P sub 1, which is equivalent to 1.25 atmospheres. Then, if the piston will expand to 88.5 liters, 88.5 liters would be our final volume. 88.5 liters. Okay? What will be the resulting pressure of the gas? So now, what is the missing term here? Our required, it is now pressure. Okay, we are now looking for the final pressure. Then, for our equation, for us to get the final pressure, remember, we are going to use the base formula, which is V sub 1 times P sub 1 is equivalent to V sub 2 times P sub 2. Since we are looking for P sub 2, for us to eliminate the different things and variables that are present on the side of P sub 2, we're going to divide both sides with V sub 2. Okay, in which we are going to arrive with the equation that P sub 2 is equivalent to V sub 1 times P sub 1 over V sub 2. Okay, so this will be the formula that we are going to use for this problem. Then proceed with the solution. For our solution, P sub 2 is equivalent to V sub 1, which is equivalent to 67 liters, times the pressure, which is 1.25 atmospheres, divided by V sub 2, which is 88.5 liters, which will now give us the answer that P sub 2 is equivalent now to 0.946 atmospheres. Okay? And if you can still recall, once again, based on the relationship that is present between pressure and volume, if the volume increases, the pressure decreases. Okay, as you can observe here that P sub 2 it is now lower than the initial pressure. Okay, remember that in the case of Boyle's law, pressure and volume are inversely proportional. The next one, let's now proceed with the GAY-LUSSAC'S law. In the case of GAY-LUSSAC'S law, he observed that the relationship between the temperature and pressure of gases in constant volume, in which the pressure of gas increases linearly with the temperature of the gas. Or technically, whenever we're talking about the relationship between pressure, which is capital letter P, and temperature, it is now equivalent to direct proportion. Okay? As the pressure increases, the temperature increases. As the pressure decreases, the temperature decreases. Okay, so in the case of GAY-LUSSAC'S law, it is now the relationship between pressure and temperature. Now, how are we going to manipulate our formula? If you're going to use the base formula, P sub 1 over T sub 1 is equivalent to P sub 2 over T sub 2. Okay, so for instance, we're actually looking for the presence of P sub 1. Okay, for instance, we are looking for the initial pressure. How are we going to manipulate this certain type of problem? The first thing that we're going to do is to obviously remove the denominator, which is T sub 1. And for us to remove this denominator, the thing that we need to do is now to multiply both sides of the equation with T sub 1 over 1, in which T sub 1 will simply be cancelled in this part. Then, it will now be written as P sub 1 is equivalent to P sub 2 times T sub 1 over T sub 2. Okay, so now, for instance, what if we are now looking for the initial temperature? Okay, the one that is now present here in the denominator. The first thing that you should remember is that we need to apply here cross multiplication. Okay, you're now going to multiply this one with this one, in which you can now rewrite this as T sub 1 times T sub 2 is equivalent to T sub 2 times T sub 1. Okay? Since we are still looking for the T sub 1 alone, we are now going to divide both sides of this equation with T sub 2 to leave T sub 1 in the numerator, in which we are now going to have the formula which is equivalent to T sub 1 times T sub 2 over T sub 2 for us to get the initial temperature. Remember, T sub 1 is equivalent to initial pressure, T sub 1 is equivalent to initial temperature. T sub 2 is equivalent to the final pressure, while T sub 2 is equivalent to final temperature. Okay, so that is how you are going to manipulate the formulas that are present in the GAY-LUSSAC'S law. Okay, now let's apply this to a problem. Our problem goes like this, and it is now present on page number 4 of our modules. A 25-liter tank of helium gas placed outside a laboratory has a pressure of 2.5 atmospheres at 20 degrees Celsius. How much will be the pressure inside the tank at noontime when the temperature reaches 34 degrees Celsius? By the way, in the case of the different gas laws, whenever we're talking about temperature, the unit that we are actually going to use here is always Kelvin. So we are going to manipulate first. We are going to convert the values of your temperature from degrees Celsius to Kelvin scale. Okay, so that is actually how we are going to manipulate the different things that is present now on your different variables. Okay, now for this problem, let's start with the given. As mentioned here, there's the presence of a 25-liter tank. Please take note that we are not going to consider volume when it comes to GAY-LUSSAC'S law. Okay, our two variables are just the presence of pressure and temperature. So we are just going to look for our initial pressure, our initial temperature, our final pressure, and final temperature. Okay, to 2.5 atmospheres. Then the initial temperature is equivalent to 20 degrees Celsius. But once again, we are going to convert the 20 degrees Celsius to Kelvin, okay? And for us to do this, we are just going to add 273.15 to this value, or 20 plus 273.15, which will simply give us the value of 293.15 Kelvin. Okay, so this is now the value of our initial temperature, 293.15 Kelvin. Then the next one, we are looking for the pressure. Then for the final temperature, it is now equivalent to 34 degrees Celsius. So like what we did, we are just going to add 273.15 for us to get the final temperature, which is equivalent now to 307.15 Kelvin, and these are now the values that we are going to use. That is for the given. Then for the required, we are looking for the final pressure. Then for our equation, so basically once again, we are going to use the base formula, which is equivalent now to P sub 1 over T sub 1 is equivalent to P sub 2 over T sub 2. And for us to isolate T sub 2, we are going to multiply both sides with T sub 2. Will now be equivalent to P sub 2 is equivalent to P sub 1 times T sub 2 over T sub 1. Okay, so this will be the formula that we are going to use. Then let's proceed with the solution. For the solution, we're just going to substitute the terms. P sub 1, which is equivalent to 2.5 atmospheres. Then we're going to multiply this with T sub 2, which is now equivalent to 307.15 Kelvin. Please take note, the unit that we are going to use for temperature is always Kelvin, okay? then the initial temperature is equivalent to 293.15 Kelvin, in which we're going to arrive with the answer that P sub 2 it is now equivalent to 2.62 atmospheres. And once again, as you can observe, the relationship between pressure and temperature. As the temperature increases, the pressure also increases. The third gas law that we are going to consider now, it is Charles' law. And in the case of Charles' law, it is not the relationship between temperature and volume. Charles observed in the year 1787 that the volume of a gas increases linearly with the temperature of gas. Or basically, whenever we are talking about Charles' law, it is not the relationship between temperature and volume, and that temperature and volume are directly proportional with each other. It is now the relationship between volume and temperature, which they are both directly proportional with each other. So it means that volume, or the initial volume, it is directly proportional with initial temperature, as well as final volume, it is directly proportional with final temperature. And now, how are we going to manipulate the formula for Charles' law? So basically, just like what we did when it comes to GAY-LUSSAC'S law, if, for instance, we are looking for the final volume, okay? For us to get the final volume, we are now going to multiply both sides of our equation with the denominator, which is the final temperature. T sub 2, or final temperature over 1, final temperature over 1 will simply be multiplied on both sides of our equation, in which it will cancel out in this part, which will now give us the formula, which is equivalent to V sub 1 times T sub 2 over T sub 1. So this would be the formula that we are going to have, and we are going to utilize for, if for instance, we are looking for the final volume for this certain type of law. And now let's have an example that is present on page number 5 of our module. A small toy car tire has a total volume of 1.3 liters at 22 degrees Celsius, which is placed outside the house. What will be the temperature in degrees Celsius of the surrounding environment if the volume of the toy car rises to 1.33 liters? Okay, so we are now going to consider here what will be the final temperature in degrees Celsius, okay? Once again, when it comes to temperature, we are always going to adopt and use Kelvin, and we're just going to convert it to Celsius and vice versa. Celsius to Kelvin or Kelvin to Celsius, depending upon what type of problem will simply be considered. Now, once again, we're going to start with, probably this is very tiresome for everyone. Let's start with G, or the given, which we have the presence of the initial volume, then the initial temperature, or the initial volume of the car tire is equivalent to 1.3 liter, while the initial temperature is equivalent to 22 degrees Celsius. Once again, we are going to convert this to Kelvin by means of adding 273.15, which will now give us the value of 295.15 Kelvin. Okay, so this is now our initial temperature. While the other thing that is given here, it is the final volume, in which our required, we are now looking for the final temperature. Okay, the final volume that is mentioned in the problem, it is equivalent to 1.33 liters. Okay, so if you're going to observe this problem, since the volume and temperature are directly proportional, since the volume increases, we are now going to assume that the temperature should also increase. And to verify that, we are now going to answer this problem. For our equation, we are now looking for the final temperature. And once again, for us to get the final temperature, we're going to use the base equation, which is V sub 1 over T sub 1 is equivalent to V sub 2 over T sub 2. Now, for us to get the T sub 2, we are going to cross-multiply both sides, in which we are now going to get V sub 1 times T sub 2 is equivalent to V sub 2 times T sub 1. Since we are looking for T sub 2, we are going to multiply both sides with V sub 1 for us to isolate the T sub 2, or the final temperature, when it comes to this equation, in which we will now be given the formula that is equivalent to V sub 2 times T sub 1 over V sub 1, which will give us the final temperature. Now, for our solution, T sub 2 is equivalent to V sub 2, which is equivalent now to 1.33 liters. Then we're going to multiply this with initial temperature, which is now equivalent to 295.15 Kelvin. And our volume number 1 is equivalent to 1.3 liters, which will now give us the final temperature, which is equivalent to the value of 301.96 Kelvin. But since we are looking for the value of the temperature in degrees Celsius, for us to get the final temperature in degrees Celsius, we are going to subtract 273.15 from the value of the Kelvin for us to get the final temperature. If you're going to subtract 273.15, it will now give us the value of 28.81 degrees Celsius, and that is our answer. Okay? As you can observe, the temperature of the environment increases from 22 degrees Celsius to 28.81 degrees Celsius because we observe that the volume of the tire increases from 1.3 liters to 1.33 liters.